All right, so this is part 2 on subtracting integers using rocks and balloons. Let's just review the questions that we need to ask ourselves. We start by saying, where are we even starting? Why? What's in the basket causing us to start there? Then we ask what's happening. Specifically, are we adding or are we subtracting? And of course today we are going to be subtracting since this lesson is focused on subtraction, but we won't always be subtracting. Sometimes we're going to go back to addition like we did before. So we always need to make sure we're paying attention to the operation. Remember that when we're adding, we are adding things to the basket that are not already there. But when we're subtracting, we have to take away things that are already in the basket. It has to be in the basket so that I can take it away. Which means sometimes I need to look at the zero pairs. If I don't have enough in the basket, we need to remember that there's infinite zero pairs available to us in that basket. We made it through all of these other problems in our last lesson. So I'm going to skip ahead to the next one. -6 minus 5 is how I would say this problem. And I'm going to let students work on this with their groups just to review, make sure that they understand, and then we'll go over it together as a class. So pause the recording as you work on it on your own first. All right, where are we starting? I've highlighted it for you. Where are we starting? Grant. We are starting at -6. Why? What's in the basket making us start at -6? Go ahead, Grant. Yeah, exactly. We have got 6 rocks in there. What's the question? I know they look like potatoes, but you try finding red rocks on the internet to use as clip art. So we have -6 because there are 6 rocks. I'm not going to forget. I always forget this part. I'm not going to forget it this time. Where's the basket starting? All the way down here at -6. Drawing that arrow so we can show. All right. What's happening? What am I doing in this particular problem? Oh yeah, we're not surprised. We are subtracting. We're going to be taking something away. What is it that needs to be in the basket so that I can take away? This is the part where a lot of students tend to struggle. They're just like, oh, -6, take away 5. I'm going to take away 5 of what's there. But the problem says we need to take away 5 what, Carter? 5 balloons. That's a positive number. So this problem is telling us 6 rocks. Take away 5 balloons. And then we look at our rocks and we're like, wait a second. I don't have any balloons, do I? There's no balloons here. So, oh no, I can't do the problem. Better give up. Or no, we move on to the next question. Do I need to look at zero pairs? Tanner, do I need to look at zero pairs here? Why? Why do I need to look at those zero pairs? Exactly. If I look at some zero pairs, can you now see some balloons in that basket? Yeah. So we need 5 balloons, which means I need to acknowledge that there's 5 zero pairs in there. So I'm going to get out those zero pairs. And now that I've acknowledged those zero pairs that are there, now I see my 6 extra rocks making it sink down to -6. I see all of these zero pairs, and now I have enough that I can take away these balloons. Now, normally I like to just sweep them away into the trash, but since you guys can't sweep them away into your trash once they're drawn on your paper, I'm going to go ahead and X them out saying, hey, that's taken away. 2 taken away, 3 taken away, 4 taken away, and 5 taken away. And each time I take away a balloon, that basket sinks further and further. 1 balloon gone, 2 balloons gone, 3 balloons gone, 4 balloons gone, 5 balloons gone. So where did this basket drop to? It's off the screen. We can't even figure out how low it is now, right? You drew them, and that's fine, but can we figure out how low it is now that it's beyond what we can see? How can we figure that out, Joshua? Exactly. We just count what's left over in the basket. We don't have any more balloons. We took those away. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when you're drawing it on your paper, if you want to draw it down so it goes down to 11, -11, then that's fine. But we have 11 rocks. So -6 minus 5 is equal to -11. But again, write yourself a note about why. 6 rocks, take away 5 balloons. That means we have to look at the balloons in the zero pairs. So I'm writing look at and take away balloons from the zero pairs. that are always in the basket, because there are always going to be 0 pairs in the basket. Whether we need them or not, they can always be there. And that's why 6 rocks take away 5 balloons is magically 11 rocks, because we're taking away balloons that were part of the 0 pairs, leaving us with only the rock part of that 0 pair. Any questions or comments or concerns so far? Okay, here's the next one. This is my favorite kind, and this is the one where a lot of you guys have tried to make up rules. We're not going to necessarily make up a rule, but we are going to make sense of the confusing things that you've heard before. So now I have 7 minus a -2. Go ahead and model this one with your group. See if you can figure it out. We're going to pause the recording as students model it. Ready, set, go. Okay, we're going to have some students up at the board modeling this problem. As you guys talk and explain, I'll talk into the microphone so it can be heard on the video. So go ahead. Okay, starting with 7 balloons. Good. Starting with 7 balloons, subtracting 2 rocks. So they're going to get those 7 balloons up on the screen. I don't know what just happened. Hold on. There you go. Okay, good job. Here, let me move that out of the way so that won't happen again. Okay, looks like we've got our 7 balloons that they said we were going to start with. And when we have 7 balloons, where does that basket go? Good. All the way up there at 7. Okay, so we don't have enough rocks, so we have to look at the 0 pairs. 5 0 pairs. Interesting. So they put the extra balloons because they were putting the balloons on as part of 0 pairs. They're getting those rocks on there now to be part of the 0 pairs. Good. And so where's that basket now? Yep, up so high we almost can't even see it. It's all the way off the screen. Good, I like this a lot. So we started off with our 7 balloons. We were supposed to take away rocks, so I'm going to write that down. Thank you guys. You guys can go ahead and have a seat. 7 balloons. Take away. And we're taking away 2 rocks, and we weren't seeing any rocks in the basket, so they said, hey, let's get some 0 pairs out. I'm just curious, how come you got out so many 0 pairs? Okay. Well, I actually really like it because sometimes we're like, well, I don't know how many 0 pairs to get. Just get 0 pairs out there. There's infinitely many possibilities of 0 pairs, so why not just have some 0 pairs on there? And I like this too because when you do take away these rocks, you can see we have a total of 9 balloons. But as we have a total of 9 balloons, there's still some 0 pairs. There's extra balloons, but those extra balloons are paired with rocks. So we do still have some 0 pairs. And I like that because the 0 pairs aren't just there when we need them. They're there all the time. Even if we're done with the problem, their 0 pairs are still there. So I like that demonstration. 7 balloons take away 2 rocks. Remember, we had to look at the 0 pairs to find the rocks. And when I look at the 0 pairs to find the rocks, that means I can take away those rocks, leaving me with just the balloon part of the 0 pair. So 7 minus a -2 made that basket go up to 9. Think back when you were first learning subtraction in early elementary school. And maybe you were struggling with subtraction and addition, and your teacher said, remember, subtraction makes things smaller. Did that happen here? Did subtraction make it smaller? It did not. So we have to be really careful that fake sort of rule that a teacher maybe made up and tried to teach you to help you, that goes away now. It's not a rule. It's not a thing because subtraction didn't make things smaller here. Joshua. Yep. Look at 0 pairs to find rocks and then close the parentheses over here. Okay, last problem. and then we're going to be able to reflect and summarize and really put this all together. So similar to our last one, 3 minus a negative 5. Excuse me, 3 minus a negative 5 is what I meant to say. Where are we starting? Why? What's in the basket? What's happening? Are we adding or are we subtracting? What is it that we're adding or subtracting? Do I need to look at 0 pairs? Go through that process with your groups, pausing the recording as you work on this with your groups. Ready, set, go. Okay, now that you have had a chance to complete it, we've got students up at the board ready to complete it. Yeah, where is the basket starting? Starting at 3. Good. It's starting at 3 because we have 3 balloons in the basket, pulling it up to 3. Keep going. Why? What in the world is happening with these 0 pairs? Why are you doing that? Okay, good. So let's pause for just a second because that wasn't explicitly stated. Pause, freeze, thank you. So yes, we're starting at 3, but then you randomly started doing this other thing. Why? Let's focus on what's happening. What does the problem say to do? Minus. Minus what? Take away what? Okay, good. And do we have those rocks? No, that's why we need those 0 pairs. Continue. Get those 0 pairs out there. Careful, you're too close to the trash. It's just going to keep eating them. All right. Great. Taking away 5 rocks. Nicely done. Hey, why are you circling those? What is that for? Those are 0 pairs. Nicely done. Extra 0 pairs. There's always going to be extra 0 pairs. Up to 8. Very good. I like it a lot. So, I'm not going to try and summarize where all of that stuff is. I'm going to write it down here. We had 3 balloons. We were supposed to take away, let's make sure we look at this problem carefully. I'm going to move the basket out of the way just so we can see. Do you see how it says 3 minus, and then what comes after the minus? The number negative 5, exactly. So that's 3 balloons, take away 5 rocks. We're like, hey, we don't have any rocks, so let's take a look at all those 0 pairs that could be there. They got a bunch of 0 pairs, then they took away those 5 rocks. When I take away the rocks that were originally paired with balloons, that leaves me with just the balloon part of that 0 pair. So I can count up all the balloons. 1, 2, 3, 4, 5, 6, 7, 8 balloons. So it's equal to positive 8. Yes, there's extra balloons, but those extra balloons are paired with extra rocks. Those are part of the 0 pairs. So 3 balloons take away 5 rocks is equal to 8 balloons. Once again, we saw we did subtraction. Did our answer get smaller when we did that subtraction? No, it was bigger than where we started. So we can't rely on that old rule that teachers may have tried to teach you, that subtraction makes things smaller, because we've seen twice or a couple times now that that definitely doesn't happen. So it's time to reflect. What happens when we take away rocks from the basket? When I take away rocks, remember that's we're subtracting a negative, we're taking away rocks. What happens to that basket? That's okay, I'll let you discuss with your groups first. The next question to go along with that is what else is going to produce the same result? And then the next reflection piece, what happens when we take away balloons from the basket? If I'm subtracting a positive, what else is going to produce the same result? Discuss with your groups. We'll reflect together as a class after you've had a chance to reflect with your groups. Pause the recording, pause the video, ready, set, go. Hands here. What happens when we take away rocks from the basket? We're taking rocks out. What happens to that basket? Gideon. The basket goes up. That's kind of a big deal. Because again, we took something away, we did a subtraction problem, and the answer grew. It got bigger. The basket goes up. What else can I do to produce the same result? What else can I do? If I want the basket to go up, what else could I do instead? Liv. We can add balloons. In other words, if we're adding balloons, what does that mean? What are we doing? We're adding. Balloons represent positives, right? So we can add positive. When I add balloons, that also is going to make the basket go up. In a similar type of questioning, what happens when I take away balloons from the basket? What's happening to that basket when I take away balloons? Luke?
It sinks.
Yep, it sinks. The basket goes down this time. Again, this is actually what you have been dealing with since second grade. When you've done subtraction problems, you have always been subtracting a positive. It's just the problems were always so carefully written that the positive number you were subtracting was always less than the number that you started with. That way you didn't end up with the negatives. So this is not a new surprising thing. We know that when we subtract positive numbers, the basket goes down. But now the question is, how else can I make the basket go down now that I'm in 7th grade and I've got all this new information about rocks and balloons and everything else? Alexis? Exactly. We can add, I'm going to say rocks, and then below I'm going to say we can add negatives. Exactly. That is also going to make the basket go down. If I put extra rocks in, that basket weighs more, so it's going to go down. And this is going to be really helpful because depending on the problem, you might prefer to think of it as taking away balloons or taking away a positive. But maybe, depending on the type of problem, it's going to make more sense to think of it as adding negatives instead. So let's take a look. These were 2 problems that we did. And we are going to practice rewriting these problems with that information, with that summary that we just did. 3 balloons take away 5 rocks. That's what this problem says. 3 balloons take away 5 rocks. If we take away rocks, the basket is going to go up. So how can we rewrite this problem to show that the basket goes up? You guys just said that when I take away rocks, that is the same as adding balloons or adding positives. So I can rewrite this problem to be 3. What? Has anyone already done that part? A few of you? Tanner, what would you do? Yeah, 3 plus. He just said 5. But he went, when we just say 5s, we're lazy and we don't say the positive part, right? So 3 plus, hint, that's a positive 5. You don't have to put that positive part, but I really like to demonstrate it early on. Look at what I'm really doing in this problem. I'm saying 3 minus a negative 5, taking away rocks, is the same as adding balloons. That's how I like to show that I'm changing it to adding a positive. That way I don't have to always rewrite the problem. I can just show it right here. Okay? And what is going to be easier? How long have you been taking away negatives? A whole day, right? How long have you been adding positives? A long time. So which is going to be easier to do in your brain? I think adding the positives. So can you make that change? 100%. 3 plus a positive 5 is equal to a positive 8. No different than when we took away the rocks by looking at the 0 pairs and then we counted everything and we had all those extra balloons. It's the exact same thing, a lot less work. Yes, Joshua? Yep, that would work for it. And now the next one, we're going to change this problem too. This problem was one that we did. Negative 4 minus 3, that's 4 rocks, take away 3 balloons. So remember, if we take balloons out of the basket goes down. So how can we rewrite this problem to show that that basket goes down? You said that taking away rocks is the same as, or sorry, taking away balloons. I misspoke. Taking away balloons. Trace, give it a try. Yes, negative 4 plus a negative 3. And again, this might not be super helpful. I think it is, because now when I have it this way, I'm like, wow, 4 rocks plus 3 rocks, what is that going to equal? Rocks plus rocks is going to equal more rocks. And so to me, that makes it easier to change that in my brain. Where this, I'm like negative 4, but now I'm taking away 3. Wait, what's going to be happening there? But if I can change this minus a positive to adding a negative, now it's rocks and more rocks is going to equal even more rocks. So that is it for today's lesson on subtracting integers. We're going to practice in the coming days. We already completed our homework in class because we did this reflection here in the video. So that's it. Thanks for watching.